Okay, I'm going to be putting these two videos together. My other video got cut off because I ran out of space. But either way, so my range is going to be all reals except y equals 0. I was explaining that it's important to have x equals 2 and y equals 0. Don't just say that your vertical asymptote is at 2. It's x equals 2 because it's a line. It's an actual line. X equals 2 looks like that. Y equals 0 looks like that. So either way, we still need to plug in some x's and get some y's. So the number one question I get is, what x do I plug in? I'm going to start out, I don't want to plug in x's over here and like -8 and -6 and things like that. I want to try a few that are close to the boundary lines. And so I'm going to try 1, 0, and -1, things like that, or 3, 4, and 5. If you really wanted to, you could plug in -8 after you've plugged in these couple, but for our purpose, we're just going to look at that. So I'm going to change the function in the graphing calculator, press graph. Again, I see that it hugs the line pretty quickly. I go to second table. See, you notice here too, this is a good thing, it says error. When I plug in 2, I get error, and that makes sense because having 0 on the bottom is undefined. Okay, so when I plug in 1, I get 1. Plug in 0, I get 0.5, 0.33, and I gotta go over here. So when I plug in -8, I get 0.1. When I plug in 3, I get -1, -0.5, -0.33. So now I'm just plotting the points. This one acts very similar to the last one we just did, but I did this last point at -8.1, so that's all the way down here. It's really close to 0. And then last 3, -1, half, a third. So I'm going to be making sure that you have these 3 points, at least 3 points, in a chart and on the graph. Okay, the only one that's a little bit different about this one is you have a constant sitting out front. All that's going to do is change my horizontal asymptote. All right, because think about it, if this is impossible to make this 0, it's always going to be something -1, so it's going to be impossible to have that -1. X equals 4 makes the bottom 0, so these relate directly to your domains and range. So all reals except x equals 4. And this one's all reals except y equals -1. So there's a boundary line. You might not be able to see that. And x equals 4 is out here. Now, I've been attempting to get you guys to try to plug this in your head, not use the calculator so much. If I try 5, 6, 7 here, it should be pretty easy to almost do in my head. 1 divided by 5 minus 4 is 1. So 1 divided by 1 is 1, minus 1 is 0. Plug in 6. You get 1 over 6 minus 4 is 2. So 1 over 2 minus 1 is -1/2. Plug in 7. 7 minus 4 is 3. So 1/3 minus 1 is -2/3. So when I plug in 5, I get 0. Plug in 6, I get a -1/2. -2/3. It's just basically getting a little bit closer to -1 as I go. Here's something that looks like that. And then if I go the other way, if I try 3, 4, and 5, 1 over 3 minus 4, 3 minus 4 is -1. So 1 over -1 is -1, minus 1 is -2. So 3, -2. Plug in 4. Oh, we don't want to try 4. I went the wrong way. I want to try 3, 2, and 1, not 3, 4, 5. 4, when I plug in 4, 4 minus 4 makes that 0, so that would be an error. So, and I don't want to head that way. I actually want to go plug in 3, 2, and 1. So when I plug in 2, 2 minus 4 is -2, so 1 over -2 is -1/2, minus 1 is -1.5, and oops. Plug in 1, I get -1/3 here. -1/3 minus 1 is -1 1/3, or 1.33 repeating. Alright, so 3 negative. I did that wrong. So you got to be careful. When I plot 3, -2, I need to go out 3 and down 2. Don't go off of your boundary line. That's what I did here, and I was off 1. So 4 was there. 2, -1.5 is right there. And then 1, -1.3 is about right there. So here's my boundary line. I'm going to go right along that. Go through my 3 points. And there's your first 3.